Hi everyone, I'm going to discuss graphs of sine and cosine functions. Now, many things in life repeat with a predictable pattern. For example, in warm areas, electricity use goes up in summer and down in winter. The price of fresh fruit goes down in summer and up in winter. The attendance at the amusement parks increases in spring and declines in autumn. Because the sine and cosine functions class repeat their values in a regular pattern, we call them as periodic functions. Now, in this figure, this shows a periodic graph that represents a normal heartbeat. Now, periodic function is a function f such that f of x equals f of x plus np for every real number x in the domain of f, every integer n, and some positive real number p. So the smallest possible value of p is the period of the function. Since the circumference of the unit circle is 2 pi, so the smallest value of p for which the sine and cosine functions repeat is 2 pi. Therefore, the sine and cosine functions are periodic functions with period 2 pi. To avoid confusion when graphing the sine function or even cosine function, we will use x rather than s. That corresponds to the letters in the xy coordinate system. Now, we will be selecting key values. For example, in graphing y equals sine x, we have to note that the period, again, is equal to 2 pi with one interval of the graph from 0 to 2 pi. So we will be selecting points. Like if we're going to select 4 points from that interval, what we will do is we will divide 2 pi by 4. So we have pi over 2 here. And we will add this pi over 2 to 0 cumulatively until we get 2 pi. So our goal here is to sketch the graph of y equals sine x in two interval from negative 2 pi to positive 2 pi. So we will be selecting some points, and dividing 2 pi by 4 will be of great help in identifying those sum points. So if this is negative 2 pi and this is our 2 pi here, which are the boundaries of period interval. So if we're going to like subtract pi over 2 from 2 pi, we'll have 3 pi over 2 here. And then we less pi over 2 again, we have pi here. And then less pi over 2, this is pi over 2. And then pi over 2 less pi over 2, this is 0. And then we add pi over 2 to 0. To the left of 0 would mean negative. And this would be plus negative pi over 2. So this is negative pi plus negative pi over 2. So this is negative 3 pi over 2. And this completes the value of x from negative 2 pi to 2 pi. Now, we intend to come up with x coordinates as quadrantal angles so we can easily evaluate its sine value. So, this is 2 pi. Well, this is pi, and this is pi over 2, and this is 3 pi over 2. So sine negative 2 pi would mean considering the y coordinates in reference to unit circle of 2 pi. So 2 pi coterminal with negative 2 pi. So whatever the y coordinate of 2 pi will be its sine value. So this is 1, 0. So this would give us sine quantity negative 2 pi equal to 0. And negative 3 pi over 2 rotates clockwise. And this is coterminal with pi over 2. Considering the unit circle, so this would be 0, 1. And its y coordinate is 1. So pi and negative pi are coterminal. So this would have coordinates equal to negative 1, 0 in reference to unit circle. So sine negative pi will be 0. And negative pi over 2 coterminal is coterminal with 3 pi over 2. So this is 0, negative 1. We have 1, 0 here, 0, 1. And then here, negative 1, 0. So for negative pi over 2, so this is coterminal with 3 pi over 2. So this would be negative 1. And then sine 0 would mean 0. Pi over 2, sine pi over 2 will be equal to 1. And then sine pi is 0. Sine 3 pi over 2. So this is negative 1. And sine 2 pi again 0. So we are now able to complete the x and the y coordinates describing the graph of y equals sine x. So plotting each point here and connecting the points into a sinusoidal curve, we have this graph. So 0, 0 is here, and then negative 2 pi 0. So this is negative 3 pi over 2, 1. So this is negative pi 0. Then negative pi over 2, or rather, we have negative pi over 2, 1, negative 1. 0, 0 is here. And then pi over 2, 1 here. Pi 0, 3 pi over 2, negative 1, 2 pi 0. So all the points here are plotted into a sinusoidal curve. So we come up with the graph of y equals sine x equal to this graph. Now we have to note that the points located on the x-axis are multiples of pi. It's actually n pi. So we have negative 2 pi, negative pi, and then 0, pi, 2 pi. How about y equals cosine x? So again, the period for cosine is 2 pi, and we're going to sketch the graph in a two interval graph from negative 2 pi to 2 pi. Since they've got the same period with sine, we'll make use of the x coordinates that we have used in the previous example. So this would be negative 2 pi, negative 3 pi over 2, negative pi, negative pi over 2. We have we have 0, and then pi over 2, pi, 3 pi over 2, and then 2 pi. And then we're going to associate this with unit circle. And these are all quadrantal angles. So this is 1, 0, which is 2 pi. And then if this is 0, 1 for pi over 2. And then negative 1, 0 for pi. And then 0, negative 1 for 3 pi over 2. And then by inspection, we'll just work on its x coordinate. So 2 pi is coterminal with negative 2 pi and its x coordinate is 1. Negative 3 pi over 2 is coterminal with pi over 2 and its x coordinate is 0. Negative pi is coterminal with pi, so its x coordinate is negative 1. Negative pi over 2, so this is coterminal with 3 pi over 2 and its x coordinate is 0. And then cosine 0 here will be 1. And then pi over 2, 0. And then pi, cosine pi is negative 1. And then cosine 3 pi over 2 is 0. And cosine 2 pi is 1. Now, plotting the points here and connecting the points into a sinusoidal curve will come up with this graph. So take note that this is negative 2 pi 1, while this is negative 3 pi over 2, 0. So this is our negative pi, negative 1. This is pi over 2, rather negative pi over 2, 0. And then we have 0, 1 here. And then pi over 2, 0. Pi, negative 1. And then here, 3 pi over 2, 0. And lastly here, 2 pi 1. Now connecting the points here into a sinusoidal curve will come up with the graph of y equals cosine x. Take note that after one period rather, which is 2 pi, the graph is repeated. How about this graph? Y equals 2 sine x. So we're going to divide 2 pi again by 4, and this is pi over 2. So we will be adding this from negative 2 pi. So this will be negative 3 pi over 2. And then plus pi over 2. This is negative pi. Plus pi over 2. This will be negative pi over 2. Plus pi is 0. 0 plus pi over 2 rather is pi over 2. Pi over 2 plus pi over 2 is pi. Pi plus pi over 2 is 3 pi over 2. So we have negative 2 pi, 3 pi over 2, negative pi over 2, and then 0, pi over 2 pi, 3 pi over 2, and then we have 2 pi here. Okay, so we'll no longer use this one. So we have negative 2 pi, and we will refer again to the unit circle. So this is 1, 0. This is 2 pi, and then 0, 1 for pi over 2, negative 1, 0 for pi, and then 0, negative 1 for 3 pi over 2. and we'll consider the sine value. So sine negative 2 pi will be 0. And then sine negative 3 pi over 2 is coterminal with pi over 2. And this is 1. Sine negative pi is 0. Sine negative pi over 2 is negative 1. Sine 0 is 0. Sine pi over 2 is 1. Sine pi is 0. Sine 3 pi over 2 is negative 1. And sine 2 pi is 0. Now, since we have a 2 factor here, we will multiply each result by 2. So this is still 0. Then we have 2, 0, negative 2, 0, 2, 0, negative 2, 0. So this will serve as the x coordinate while the last row will serve as the y coordinate. So plotting the points, so let us assign this as pi over 2, pi, 3 pi over 2, and this as 2 pi. So this is negative pi over 2, negative pi, negative 3 pi over 2, and then this is negative 2 pi. So let's assign this as 1, and then this as 2, negative 1, this as negative 2. So plotting the points, we have negative 2 pi, 0. So this is negative 2 pi 0. And then negative 3 pi over 2, 2. Here, negative pi 0. Negative pi over 2, negative 2. And then 0, 0. Pi over 2, 2. And then 3 pi over 2, negative 2. Um, oh, we forgot the pi over 2 here. So let's just place pi over 2 here. So for pi over 2, we have sine pi over 2 is 1. Okay? And then sine pi over 2 is 1. So 2 times sine pi over 2 is equal to 2. So we should have a point in between pi to 3 pi over 2, which is, oh, we have, we're done with pi over 2, 2. So pi 0 now. And then 3 pi over 2, negative 2. And then finally, 2 pi 0. And then we will connect the points into a sinusoidal curve. So that's the graph of y equals 2 sine x. Take note, class, if we're going to compare this with the graph of y equals sine x, this graph is taller than the graph of y equals sine x. And with that, we associate that with amplitude. The amplitude is always equal to absolute value of A. Now, if there is no value before sine, that would mean amplitude is equal to 1. So let's summarize what we have done in this lesson, take note that the graph of sine function as well as cosine function is continuous over its entire domain, negative infinity to positive infinity. Meaning, going back to the graph, so there is no discontinuity as regards to the domain. Okay. Its x-intercepts are in the form of n pi, where n is an integer. Again, x-intercepts are the points located on the x-axis. So if you notice with the graph of sine function, the x-intercepts are in the form of n pi. So usually multiples of pi, like negative 2 pi, negative pi, 0 pi, 2 pi. And like with cosine function, so it's in the form quantity 2n plus 1 all over pi over 2. That's why if you notice, the x coordinates are with denominator 2 always. So its period, both the sine and the cosine are equal to 2 pi. Now the graph for sine function is symmetric with respect to the origin, while the graph of this cosine function is symmetric with respect to the y-axis. In the next discussion, we will still be working on the graph of sine and cosine function. This time, we will be working on translation, or the horizontal and the vertical translation of the graph of sine and cosine function. So we are referring to the movement of the graph. Okay, so that's it for now.